Hello students. In this video we will study about the potentiometer. It is clear from the name of this device that this device measures the potential difference between 2 points of any electric circuit. But this is not complete introduction of this electric device. So this device can measure the electromotive force of any cell, or this device can also measure the internal resistance of any cell. So what is the complete introduction of this device? The potentiometer is a device which is used to measure the electromotive force of any cell or internal resistance of any cell or the potential difference between 2 points of any electric circuit. So this is the complete introduction of this device. Okay, some persons say that potentiometer or meter bridge are not device, but we know that potentiometer or meter bridge are made for some purpose. So the definition of device is that the arrangement is made for any purpose. So that is called device. So meter bridge is device and potentiometer is also device. Now we will discuss about the construction of potentiometer. In the potentiometer, here rectangular wooden board is taken and 4 to 10 wires of length 1 meter. The length of each wire should be 1 meter or 100 centimeter are connected in series over the wooden plate. How? So this is first. This is first wire, second wire, third wire and fourth wire. We can connect here more than 4 up to 10 wires. Okay, these wires must be of alloy. Okay, why? We will discuss about it. So the first end of the first wire is soldered with this strip. This is the strip. These strips should be of metallic strips. Metallic strips. Generally, we are taking here the copper strips. Okay, so with the copper strip, the first end of first wire is soldered at point E, and the second end of first wire and first end of second wire are soldered with the copper strip, and the second end of second wire and first end of third wire are also soldered with this strip. And here the second end of third wire and first end of the fourth wire are soldered with the copper strip. Okay, and this is the second end of fourth wire. We can connect here more than 4. Okay, now this is the second end of first and this is the first end of second. So these are in series. Similarly, here this is the second end of second and this is the first end of third. So these are in series. Okay, now and one side of this wooden board, here 1 meter scale is to measure the distance of null point. Okay, and in this potentiometer, here between point A and B, here a battery is connected. This battery is called driving battery. What is this? This is called driving battery or driver battery. Okay, and with the in the series from this battery, here key is connected and this is the rheostat to change the current flowing through the wire. Okay, this is the basic construction, and this is the simplified diagram of the potentiometer. these wires are connected in series. So we are showing here the length of the combination A between A and B. Okay. Now this is the battery. So with the point A, here battery is connected. This battery is called here driver battery, and this circuit is complete. This circuit is called driving circuit or primary circuit. Okay. If we want to measure the potential difference of any electric circuit or the EMF of any cell or the internal resistance of any cell, so we connect the cell or the electric circuit between point A and galvanometer. Okay, so here we have to connect. Okay, and this is the galvanometer, and the galvanometer is connected to the jockey. Okay, this is the simplest diagram. Okay, now we will discuss the principle of the potentiometer. What is the principle of the potentiometer? Okay, first of all we have to clear why here in the potentiometer alloy wires are taken, because alloy has the more resistivity or the more resistance. Okay, and the temperature coefficient of alloy is very less. If the current is flowing for long time, then here electric heat is produced in the wire or in the conductor. Okay, due to this, here temperature of the conductor or wire is increased. Okay, if here the alloy is taken, so because the temperature coefficient of alloy is very less, that's why wire has some resistance. That's why here potential will be dropped. Okay, potential will be dropped when here, if here this is connected to the positive terminal and this wire is conductor or metallic wire, so here through this wire potential drop will not be there. And because this is the alloy wire, the resistance or the resistivity is more than the metallic wire of this alloy wire. That's why here potential will be decreased with the length. Here if we are going along this direction, then potential will decrease, potential will decrease, potential will decrease. Okay, means here potential decreases means potential drops is there. Okay, now this potential drop or potential uh, decreasing potential with the length of the wire, so potential drop is directly proportional to the length of this wire. This is the principle, basic principle of potentiometer. Okay, now we have to find this relation. So how will we find? Here you know, if current is flowing through the through AB wire, then here potential will be decreased at the potential at point A will more than that of the potential at point J. Okay, means potential decreases with the length. Let the length of AG is equal L. Okay, now you know that the potential difference by Ohm's law, potential difference V is I into R. But R, what is R? R is equal rho L upon A. You know, in the already we have studied about the relation between the resistivity of the wire and the resistance of the wire. This is the value. Now, on putting the value of R in this equation, V will be equal I into value of R, rho L upon A, rho L upon A. Okay, you know the current, if current does not change and the resistivity of any wire for a material is constant, when material changes then the resistivity will be changed, but here material or the wire does not change, that's why rho will be constant, and A is the cross sectional area of this wire AB. So this value and these are constant, so V will be equal, we can write K in the place of I rho upon A into L. So V equal K into L. Okay. Or the K is constant. That's why here this is equation number first. So from equation first, V is directly proportional to L. This is the principle of the potentiometer. Okay. This is equation number second. From equation first, here K will be equal V upon L. What is this? This value is, V is the potential drop with respect to length of the wire. Okay. So the potential drop with respect to length of the wire, or the potential drop with the length of the wire, is said to be potential gradient. What is potential gradient? Again, what is potential gradient? The potential drop per unit length of wire AB called the potential gradient. So this is the formula of potential gradient, and this is the definition of potential gradient. Okay, this is. And what will be the SI unit of the potential gradient? Because the SI unit of V, potential or the voltage, is volt, and the SI unit of length is meter. So what will be? Volt per meter. We can write it volt V M inverse, volt per meter. But practical unit of the potential gradient is volt per centimeter. Volt per centimeter, because the length of this wire is measured in the centimeter. Okay, and that's why this the unit of potential gradient is volt per centimeter. To compare the EMFs of two cells, here two cells are taken. Let the EMF of first cell is epsilon 1 and the EMF of second cell is epsilon 2. The positive terminal of each cell is connected to the point E, and with the key K2, here negative terminal of each cell is connected to the galvanometer, and with the galvanometer here jockey is connected J. Okay, now the cells are brought in the circuit one by one. So if this we have to bring the first cell in the circuit, then here the key is inserted, this key is inserted, then this cell will be in the circuit. Now if this cell is in the circuit, so for this cell jockey is brought near the point A, then deflection will be one side and left hand side, and now this jockey is brought near the point B, then the deflection in the galvanometer is opposite side. Okay, second step is that this jockey is brought near the point A, and this jockey is sliding over the wire AB. Okay, then the deflection in one side is it's decreased slowly, and at any point the deflection in the galvanometer is 0. In this condition, here the deflection on the galvanometer is 0. This point is said to be null point. Let this is null point is N1 for first cell. You can see this cell is not in the circuit, only first cell is in the circuit. So you know A, this cell, and this is closed, so this G and jockey point N, and this is the loop, this is the loop. So we can apply here A to cell, cell to G, G to N1, and N1 to A. So this is complete loop. A and cell and G, and this is point N1, and again A. In this closed loop, here we are going along this direction, anti-clockwise. So this EMF epsilon 1, and the sign of epsilon 1 will be, because we are going positive to negative, so this is negative, that's why here negative will be there. Now here galvanometer, in the galvanometer, because the current is 0, means Ig equal 0, and in this circuit current is flowing along this direction. Okay, so here Ig into G will be there, but Ig equal 0, and this is plus, because the current direction of current is along this direction, and we are going opposite to the current, that's why here will be positive. Now here at point N1, we are going N1 to A, so the potential difference between A and will be equal VA N1, and what will be the sign? The direction of current is along this direction, and we are going opposite to the direction of current, that's why here will be positive, and it will be equal 0. Okay, now we can write this VAN1 will be equal, on transposing in right hand side, so it will be epsilon 1. Okay, but by the principle of potentiometer, we have V, A and J equal K into L1. Let this is the null point for first cell, the distance of null point is L1. So K L1 will be there. Now on putting the value of VAJ1 in this equation, so epsilon 1 will be equal to KL1. Okay, now second cell is brought in the circuit. Then here key is inserted, and this key is taken out. So now this cell is not in the circuit, second cell is in the circuit. Now for this cell, let the null point is this N2. So again, in applying the Kirchhoff's second law, here will be A and G, G2, N2 and A. In this closed circuit, this is the potential difference between two terminals of the cell. This is equal epsilon 2, electromotive force. The direction will be, we are going positive to negative, that's why here negative will be there. Now in this galvanometer, Ig is 0, so here 0 into G will be there, where G is the resistance, here also G is the resistance, and the direction this will be positive, And now between point N to N A, we are going N2 to A, and the direction of current is A to N2. That's why here plus, and potential V A N2, it will be equal 0. Okay, now from this equation can be written as V A N2 equal epsilon 2. Okay, or epsilon 2 equal V A N2. But by the principle of potentiometer, V A N2 is equal K L2, where L2 is the balancing distance, and K is the constant. This constant is called potential gradient. So this is for a second cell. Now on putting the value in this equation, so what will be there? Epsilon 2 will be equal KL2. Okay, this is second. Then dividing equation first by equation second. So what will be here? Epsilon 1, this is first, na? Epsilon 1 upon epsilon 2 equal KL1 upon KL2. K cancel by K. So here epsilon 1 upon epsilon 2 equal L1 upon L2 will be there. This is the required expression or required formula to compare the EMFs of two cells. Okay, it is easy. In some books directly this is given, and here epsilon 1 equal KL2, KL1. First equation is this and second is this. In some books directly these equations are given, and dividing, and in this derivation is found in 4 steps: first, second, third and fourth. But how epsilon 1 is KL1, how epsilon 2 is KL2, okay, you do not know, na? That's why I have cleared all the concepts